All right, so in the last video, we spoke about looking at a question that's a little bit different. And this one is a bit different in a couple of ways. All right, so the first thing I am going to do is I have written this question out because typically what I've done is giving you your dividend and your divisor and said find a quotient. That's not how these questions are going to look on a test. And so it's important for you to see how they look on a test and how they're worded. This question in particular has the wording, use long division to find the quotient and remainder of 16x to the fourth minus 1 divided by 4x squared plus. Now, this is different in a couple of ways. And the first way is that there are two approaches that we can definitely take to resolve this issue. The first one we already know is long division. But the second one, I mean, it should pick up on it. If you look at the dividend, let's look at the dividend, right? So our dividend here, and let me get this onto, if I can, pencil. Give me 1 second. All right, so we should be in focus now. Let's see if we can get this done. 16x to the fourth minus 1. Now I'd ask in a classroom, I'd say to you, what's special about that dividend? And you should see a topic there that looks familiar, or at least a format that looks familiar. And the first thing you should say to me, this looks like something from factorization. And I'd say to you, expand on that, what from factorization specifically? And you'd say to me, well, there's a difference there. And hopefully you'd say to me that these look like perfect squares on either side of the difference. And I'd say to you, that's great, because that difference between two squares. And whenever you have a factorization, that's one of the very first things that you want to look out for, because it makes your life very easy if you can see it. Now, what are the squares? And with a difference between two squares, the heavy lifting is literally identifying what the squares are. So if we look at 16x to the fourth minus 1, the first thing you should say is that 16 can be represented by 4 squared. X to the fourth can be represented by x squared squared. So we're looking at 4x squared all squared. And then on the other side of that difference is 1, which we should know from that topic is the same thing as 1 squared. Because you know your perfect squares numerically, right? Your square numbers, 1, your 4, what else? 9, 16, 25, so on, so forth, right? All square numbers, so you should be able to recognize them when you see them. So now we have our squares written as a difference of two squares. And what that means for us is that the factorization becomes the first one plus the second one times the first one minus the second one. And does it matter whether it is 4x squared plus 1 first or 4x squared minus 1 first? It shouldn't matter, because multiplication is commutative, in that if I said 2 times 3 is the same thing as 3 times 2, right? So however you decide to write this, that's up to you. But then the question is, how does that allow us to solve this question or find our quotient, right? Now, if I can scroll up here, and this is going to be, again, heavy lifting for us. Let me see whether or not I can get that done. Shift something around here, and let's see if we can scroll now. There we go. All right, so if I say to you, I have 16x to the fourth minus 1 divided by 4x squared plus 1, it's the same thing as, because we know our numerator can be rewritten as 4x squared plus 1 times 4x squared minus 1. Then when we're dividing by 4x squared plus 1, we can see that there's cancellation. So we'll get that cancellation here. And so our quotient, really quickly, in a couple of lines, is 4x squared minus 1. So this would be the result that we'd expect from our polynomial long division. Now let's see if we can get to that division really quickly. All right. So I have a clean slate here, and we want to get to our long division. All right, so we have, as we said before, 4x squared plus 1 as our divisor, and 16x squared minus 1. Or sorry, 16x to the fourth minus 1 as our dividend. Now, here is where it's a little bit problematic, right? This is not the format that we're used to seeing. The format that we're used to seeing is descending powers of x in our dividend. Now, the question that I would ask is, can we express this as descending powers of x in that dividend? and we should be able to, right? We've been doing it to an extent in terms of rewriting, where we use placeholder values. So where I don't have a term in x cubed, I could put 0x cubed. Where I don't have a term in x squared, I can put 0x squared. Same thing for a term in x. And finally, we have the -1 that we're given before. Now, can we divide here? And it's going to be the same process that we're accustomed to. It's going to be our leading term, 4x squared, dividing 16x to the fourth, if we can. And 4 goes into 16 to give us 4. X squared goes into x to the fourth to give us x squared. And all we have to do now is multiply this term here, which is our quotient, by the divisor. So we end up with 4x squared times 4x squared, which gives us 16x to the fourth. And then we have 1 times 4x squared, which is just going to give us 4x squared. And for everything else, we put a placeholder so that we can subtract in line as we have before. So 16x to the fourth minus 16x to the fourth gives us 0. 0x cubed minus 0x cubed gives us 0. 0x squared minus 4x squared gives us minus 4x squared. 0x minus 0x gives us 0x. And -1 minus 0 gives us -1. We're almost there. Now, our new dividend is going to be -4x squared minus 1, and we're going to divide through that first term by our leading term here, which is 4x squared, right? So we get 4 into 4 into -4 giving us -1, and x squared into x squared also giving us 1. Now, all we have to do is multiply through our -1, which is our partial quotient, by our divisor, and we can subtract, and that will be the end of it, right? Because we have 4x squared times -1, -4x squared, and 1 times -1, which is just +1, right? Or sorry, 1 times -1, which is just -1. All right, let's clear that. And if we can, if this thing doesn't give too much trouble, we should be able to fix this really quickly. Oh, almost there. Erase. All right, so this does, all right, let's just erase it. And then rewrite what we need to rewrite. So I have -0. All right, so we're good. So -4x squared minus a -4x squared, that gives us 0. 0x minus 0x, 0. And then, of course, a -1 minus a -1, which is -1 plus 1, which is also 0. And as we expected, we end up with a remainder of 0. And we already knew this to be the case because we already worked this out in the prior page with a difference between two squares. So our quotient in this case, of course, is 4x squared minus 1. And that is because 4x squared plus 1 is a factor of 16x to the fourth minus 1. All right. A little bit different in terms of the way we approach the question, but it was one of those questions where it's good to have a call back to what you did before and be comfortable in that space. So hopefully you enjoy the process. That's my dog in the background contributing in an amazing way to this video. Like and subscribe when you get the chance, and we'll do our best to put out some more content for you.